My name is Catherine Lloyd, and I'm here to present to you the Peppermint Choco Bar with my partners Maria Cortez and Mia Ibarra. In this project, our job was to create a candy bar. The purpose was to find the maximum volume of this candy bar, and as a result, we determined that the maximum volume of our candy bar was 8,191.4 centimeters.
Hi, I'm Maria Cortez, and continuing off of what Kat said, basically for our trapezoidal prism, or a trapezoid, basically we just kind of took a long rectangular sheet of paper, which was 27 inches long and 22 inches wide. And basically what we did was we signified the different variables. So this long part right here, which would be the base of the actual trapezoid itself, was going to be the big B variable. Onto the sides of it would be the Z variable, and then the height, which would eventually turn up that way, would be the H, and then the X, which was the actual sides of the variables. Yeah, so that would be the X. And basically what we did was we labeled all of that and we came up with different equations. So for this 27, for it to equal 27, we came up with 2x plus big B plus B. And the reason why we put 2x is because there's two x's on the side of the length that goes that way. There's one big B and there's one little b, which should equal to 27. And then for the for the widthwise, you would have 2h plus z, and that's because there's two h's on both sides, and then there's one z, and that would have to equal 22 inches. And so whenever you get down to those, you would also have big B equals B plus X, and then H equals a square root of 3 over 2 times X. And then whenever you get all of those four equations and you try to simplify it, you get 2x plus little b plus x plus b, because the big B ultimately equals to b plus x as signified over here, and that equals to 27. So you would also have 3x plus 2b equals 27, because whenever you combine like terms, you basically get 3x plus 2b. And then whenever you're trying to solve for it, or I guess reduce this equation, you would have 2 little b equals to 27 times 3x. And then you divide by 2 on across both sides, which equals to little b equals 27 minus 3x divided by 2. And then whenever you plug in this equation, or the h into this equation for I think it's v over there, you would have 2 times the square root of 3 over 2 times x plus z equals 22 for the lengthwise, or for the widthwise. And then for z, it would be equal to 22 minus square root of 3 times x. And basically all of these equations are just a bunch of different variables that we had to ultimately reduce to one single equation of x. And basically that equation was based off of the volume variable, which over there it's equal to volume equals to big B plus little b divided by 2 times h times z. So we had to take all of those variables, which is the big B variable, the small b variable, the h variable, and the z variable formulas, and plug them into the equation. So we would ultimately have v equals to 27 minus 3x divided by 2, which is the big B variable, plus x plus 27 minus 3x divided by 2, and that's all of that's divided by 2 as per the equation, times the h, which was the square root of 3 times 2 times x, and then times the z, which was 22 minus the square root of 3x. And so immediately you can see how we removed all of these variables by substituting them to equal to x and reducing them. So this would all equal to one equation of the variable based off of x, and then you would ultimately plug that into the equation, find the maximum, and that would be the variable that you would get for x. That would be your x value, into which you plug that into the equation again, and the different equations that you had in the beginning to give you the length and measurements of your trapezoidal prism. And then you convert them to centimeters, which would be you would multiply whatever numbers that you got times 2.54. So right here we see the equation in which we graphed all of that formula, and that would equal to 4.361, 498.63. However, we should only pay attention to the x, because that is the value in which we would substitute the other x's for in the equations that we had before. And so this maximum right here entails basically the x that we were looking for through the equation.
Hi, okay, now let's move on to the next part of the project. Now I'm going to state the construction of our trapezoid, but also the procedures. First, first, we determined that the variable h would represent the height of the trapezoid, x would represent the slant of the trapezoid, capital or big B would represent the base of the trapezoid, little b would represent the small base, and z represents the length. Next, we created a system of equations using the variables I just listed. To find the volume of the trapezoid, we solved for the length, the small base, and the height. Once we had our system of equations, we plugged the equations into the formula for the volume of a trapezoid. Once we plugged the equation into the calculator, we found that x, the slant of the trapezoid, is 4.36 inches, but which we multiplied by 2.54 to give us 11.1 centimeters. Then, once we found x, we were able to determine that big B, or big base, was 11.3195 inches. We then multiplied that by 2.54 to give us 28.8 centimeters. Then, for the rest of these, we converted them into centimeters as well. So for small base, it is 17.7 centimeters. And then, the length is 36.7 centimeters. The height is 9.6 centimeters. And now that we have all the numbers needed, we found the volume of our trapezoidal prism.
Now onto the official construction of the process. As soon as we gained all those measurements for the centimeters, the reason we got the centimeters instead of the inches was the fact that the ruler was able to correctly state the inches and as well as the decimals that came along with it. And so in the further construction of the actual trapezoid itself, we referenced the centimeters to enable us to get the most accurate representation of what we gathered from the equations themselves. And so in construction of this, we basically just measured to the points of all of 11 centimeters for, like the eggs and stuff like that, and to the point where whenever we measured all of them and it became like these lines on a paper, we basically just got a ruler and then we put it onto the line and then we folded it so that it would be able to be folded better. And then after that, in construction of the actual trapezoid itself, because in construction of the rectangle, we were able to actually put it right there. But for the actual triangle itself, we didn't use a protractor to measure the 60-degree angle in which we needed to actually have the fold that was correctly described. Instead, we used the equation of x divided by 2 to correctly gain the measurements for the trapezoid itself, so that way we would be able to measure it correctly, and then in the aforementioned future, be able to fold it and then correctly tape it together, which would end up into this masterpiece right here.
Yeah. Basically, after like all that, we get this lovely big boy.
As for our final conclusions, we get the KM Square, which is now in the Holiday Spirit Special, which is the Peppermint Choco Bar. And basically, after all of these equations with the big B plus B, little b divided by 2 times h, and the ultimate volume equation, which we base every individual variable off of, which is big B plus little b divided by 2 times height times z, we get this trapezoidal prism.